This lesson is exponential equations. An equation of the form b to the cx equals a, where the exponent includes a variable, is an exponential equation. You can solve an exponential equation by taking the log of each side of the equation. Here's an example. We're going to find that the solution for the equation 3 to the x plus 2 equals 7, correct to 6 decimal places. We've got 3 to the x plus 2 equals 7. I'm going to take the log of both sides. Remember, one of the properties of logs was that these powers could fly to the front. That's how we get the x out of the exponent here. So let that power fly to the front. Now we're going to solve for x. I've got x plus 2 times the log of 3. Let's go ahead and divide the log of 3 away and then subtract the 2. It's calculator time. We'll throw that in a calculator and round it off to 6 decimal places, and there we go. So logs can help us solve equations that we couldn't normally solve without them very easily. Here's another example. We're going to solve log of 7 to the 3x equals log of 20. We're going to bring that 3x out front and divide by log 7 and then divide by 3. If you want, you can write the divide by 3 here, or you can write it down here as 3 log 7. Put that in a calculator, and out comes a solution. Try one. Solve this round to the nearest 10,000th and try to check your answer. If we take the log of both sides, let the x fly to the front. X equals log 4 over log 3, which is approximately 1.2619. To check it, we would try 3 to the 1.2619 and see how close to 4 we are. We should be fairly close. Here's another one. 6 to the 2x equals 21. Try that one. Log of 6 to the 2x equals log of 21. We can go ahead and divide both sides by log of 6 at this point, and then divide by 2. Calculator time, we get approximately 0.8496. Try this one. Take the log of both sides, let the power fly to the front, divide by the log of 3, subtract the 4, pick up a calculator, and there's our result. Let's apply this a little bit. We've got an investment of $2,000. We're earning 5 3/4% interest, which is compounded quarterly. After approximately how many years will we have $3,000 worth if we don't make any more deposits or withdrawals in that investment? Remember the formula. The amount we will make is the principal times 1 plus our rate divided by our number of compounding times per year to the number of compounding times per year times the number of years, t. So let's plug in everything. We're trying to get the $3,000. We have $2,000. 1's part of this little formula. 5.75% is this decimal. We're compounding quarterly. That's 4 times a year to the 4 times number of years power. So we've got a t here. This is what we have to solve for. Let's see what we can do. If we divide both sides by 2,000, we can make it a little simpler. We can take the 1 plus the decimal here and make it a little simpler. So we've got 1.5 equals 1 point long decimal to the 4t. To solve for t, we're going to have to take the log of both sides so we can get the t out of the exponent here and down here where it belongs. Divide both sides by that big long log and divide by 4 also, and t equals approximately 7.1 years. So it's going to take just over 7 years to grow another $1,000 out of our $2,000. That's our learning target for today. I'll see you in class.